Hello everybody, welcome to my YouTube channel. So previously we saw the normal distribution or the Gaussian distribution. Today we're going to see a concept known as the z-score. So let's say we have a data set with a mean, that is the mu, equal to 4 and the standard deviation equal to 1. Okay. Now we're going to plot this to get our normal distribution graph. So you have different values here, 1, 2, 3, 4, 5, 6, 7, okay, and then you'll do your graph, which is the normal distribution. Okay. Right. And the mu is here, it is in the middle, so it falls in the middle, 4 is in the middle. This is the mean of our data set. Okay. Now let's say I want to know where does 4.5 fall in terms of standard deviation. This is very important, okay? In terms of standard deviation in this graph. Where does it fall in terms of standard deviation in this graph? Okay? Where does 4.5 fall in this graph in terms of standard deviation? So you look at this graph, you will tell me that it's quite easy. Maybe it's around here in the middle of 4 and 5, you get 4.5. Previously we learned about standard deviation. So if we take number 5, it is one standard deviation to the right. So from the mean 4, 5 is one standard deviation to the right. So then what is 4.5? It is obviously 0.5 standard deviation to the right, isn't it? So it is 0.5 standard deviation to the right. Okay. Now this is quite easy. Let's say we have 4.75. Sorry, 4.75. Okay. This is a little bit more complex and it's very direct. You want to know where does 4.75 fall in this graph in terms of standard deviation. This is where we have the concept of z-score to help you calculate in terms of standard deviation the number, where does the number fall in the graph. So this is where z-score comes into play. Z-score, we have a formula. Let me write it here so that you can see better. So the z-score formula here is x of I minus mu divided by the standard deviation. This is the formula of z-score. Now we want to see where does 4.75 fall in terms of standard deviation in this graph. We will use the z-score. So let's apply the formula to find this out. We'll take the x of I, which is 4.75, minus our mu. What is our mu? Our mu is 4, divided by the standard deviation, which is 1. What do we get? 0.75. Now, you see that 0.75, it is a positive number. It is a positive number. So what does it mean? When it is a positive number, it is always the standard deviation to the right. We always say that if it is a positive number, it is the standard deviation is to the right. So 0.75, it's to the right here, positive. So it's 0.75, where you will see where does 4.75 fall in the graph. Okay? So 4.75 is around here. Okay. Now let's say we want to see where does 3.75 fall on the graph. Where does it fall on the graph? Similarly, you will apply this formula to see where does 3.75 fall on the graph in terms of standard deviation. So let's see. 3.75. So let's calculate the z-score. So it will be 3.75, which is the x of I, minus mu, which is 4, divided by the standard deviation, which gives you minus 0.25. So here you already get a clue. If it is minus 0.75, it is already a negative number. You can see it is a negative number. And if it is a negative number, obviously it is to the left. Okay? And positive, it is to the right. This is very important so that you can have a clue of where does the number fall. Is it to the left of the mean or to the right of the mean? So minus 0.25. So it is around here. You will see your 3.75. So it will be minus 0.25, which is to the left. And this one is to the right. I hope you're able to see the concept of z-score, on how you can use z-score to be able to determine where does a number fall in terms of standard deviation in the normal distribution graph. So I hope this is clear and that you understood about the z-score concept. Thank you for watching the video. Bye bye.